Hello, I'll be doing the demo. So on the right here we have Asterinas. It's implemented in safe Rust. So it's implemented in safe Rust and enforces safe Rust. So hopefully making it memory safe. Now inside this, it's basically Linux. So this one's running inside a VM, which is inside a Docker container. And the goal of this demo is we'll be showing a simple buffer overflow inside the module. So here inside, the vulnerable code is inside here. So it's here we see this one's the vulnerable code, and we're gonna make a HTTP server that allows an outsider to interact with this module and then cause some buffer overflow. So we are going to before that, so we're going to run it in port 8080. We're going to connect to the Docker container. So here now we're inside the Docker container, and this one's a VM running inside the Docker container, so we can essentially, these two can talk to each other. So if we look for the forwarded port, here 59952, we can essentially hi, and okay, so we write hi, and if we test, so this one is just this was not essential for the buffer overflow, but it's just a test to showcase it. So here, so in a normal password setting you wouldn't be able to see the stored password. We see it here just to show the buffer overflow in action. So here we see hi, we see secret password. So in other cases, like if we post the like that and then check it out, it should work. So this is a normal way of doing it. However, if we just write a long string of A's, we check, oh, well, that's exactly the amount of characters that we need. If we, so in normal circumstances there should be a bound check. However, in memory unsafe languages like C and C++, they don't do bound check unless the programmer has explicitly added. Rust, hopefully, supposedly, if you write it in safe, it should do bound checks. But here we see that the buffer is being overwritten. Continually seeing some writing happening over here. So what happens if we continuously send a long string of A's is that we overwritten the stored password and the input buffer becomes the same, so we get an access granted. So obviously this is not, the demo itself is not very damning, but what we can see here is that although we have written this module entirely on safe Rust, we can verify using here. So if we see here, we see that the deny unsafe code is inside the Rust library. Also the implemented library, also we don't have any unsafe blocks inside of it. We still see that buffer overflow can be triggered. So that is it for the simple demo. Thank you.